Hello everyone, this video will show how to evaluate logarithmic expressions without using calculator. Now let's go over this first example. So we're given log of square root of 10. The first step that we need to do in order to determine the value for this is to set up this whole expression with a variable. Say for example, we will take this whole expression as equal to x. And then from here, we go ahead and change this logarithmic expression into its equivalent exponential form. So this is the general rule right here. So we go ahead and remember that the invisible base for logarithm, if it's not written there, that is 10. So this is 10 raised to the power x, which is this value that we have here, is equal to square root of 10. So we go ahead and change this square root of 10 into a fractional exponent form. Now we remember that in this expression, we have an exponent of 1 on the 10, and the invisible index we have here is 2. So we can go ahead and say that this expression would come out. So this is the equivalent rational exponent form for square root of 10. So the exponent here will go to the numerator. This value that we have here, which is the index, will go to the denominator of the fractional exponent. If you notice, both sides of the equation have the same base of 10. If the two bases are the same on both sides, we can go ahead and say that their exponents are also equal each other, so that our x value is 1/2. This tells us that this whole expression log of square root of 10 is 1/2. So this x here represents the value for this whole thing. Now let's have another example. In this example, we're given log base 3 of square root of 3. Again, to evaluate this expression, we will have this expression equal to a variable, let's say y here. So we can go ahead and change this given logarithmic form to its equivalent exponential form using this rule right here. So we have 3 raised to the power y. So I got the base 3, and that's raised to the power y is equal to square root of 3. From here, we can go ahead and change this square root of 3 to its rational exponent form. Remember, there is an exponent here of 1, and then the index here is 2. So we can go ahead and rewrite this as, if you notice, both bases that we have on each side are the same, so that we can go ahead and say that their exponents are also equal. So this is y is equal to 1/2. So this tells us that log base 3 of square root of 3 is 1/2. Now let's have another example. In this example, we're given log base 25 of square root of 5 raised to the power 6. Again, we will equate this expression with a variable, let's say x here, so that we can go ahead and change this to its exponential form. That's 25 raised to the power x is equal to square root of 5 to the power 6. Now we can go ahead and change this into rational exponent form. Since we notice this is a 5 and this is 25, we can rewrite this 25 with a base 5, and that is actually 5 squared. So this expression would come out. The reason why this is 6 over 2, it's because we got a 6 here. And remember the index that we have here, it's an invisible 2. So that's how I got the 2 there. So that we can go ahead and simplify this further. So what I did here was I used the property of exponent. So 2 times x would be 2x. 6 divided by 2 is 3. Now if you notice, their bases are the same for both sides, so we can go ahead and say that their exponents are also equal to each other, and we can solve for x from there. So I'm just going to go ahead and show the work down here. So we can go ahead and say that log base 25 of the square root of 5 raised to the power 6 is equal to 3/2. Now let's have another example. In this example, we're given log base 2 of the cube root of 16. Again, we're going to set this up equal to a variable, let's say x here. So we can go ahead and change this to its exponential form. 2 raised to the power x is equal to the cube root of 16. Now we remember that this 16 is an invisible exponent of 1, so that we can go ahead and change this 16 into its fractional exponent form, and this is how it's going to look like. So this invisible one here will be the numerator, and then this 3 here will be the denominator. Now notice that their bases are not the same, so we need to make sure that their bases are the same. This 16 can be expressed as an exponential form, that is 2 to the power 4. So then we can go ahead and rewrite this as, so what I did was 16 can be written as 2 to the power 4, and then that's raised to the power 1/3. So that we can go ahead and simplify this further. So when 2 is multiplied by 1/3 is 4/3. Now if you notice in this equation that we have here, both bases on left and right side of the equation are the same, which is 2. If both bases are the same, their exponents are equal to each other. So that we can go ahead and say that our x is 4/3. So this tells us that this whole expression that we have here is equal to 4/3. Now let's have another example. In this example, we're given log base square root of 2 of 16. Again, we're going to set this up into a variable, let's say y here. So this whole thing is equal to y. And so we're going to solve for y. So we're going to change this into its exponential form. Square root of 2 raised to the power y is equal to 16. So this square root of 2 can be written in fractional form because this one has an invisible numerator of 1 and the index here is 2. So we can go ahead and say that square root of 2 is actually just 2 raised to the power 1/2. And then we have a y right there. And notice that this 16 can be expressed as a exponential form with a base of 2, and that is 2 to the power 4. So we can go ahead and simplify this further as, so what I did was I multiplied 1/2 with y, so that gives us y over 2, and that's 2 to the power 4, so that we can go ahead and say that their exponents are the same because their bases are the same. So I'm going to go ahead and show the work to solve for y here. Since we want y by itself here, we want to get rid of the 2 here. So what we do is we are going to multiply this by 2 over 1 and multiply this by 2 over 1, or pretty much 2. So that from here we can go ahead and cross out 2 and 2 here. We are left with y. So that tells us that y here is equal to 8. So this whole expression that we have here is equal to 8. Now let's have another example. To find the value of this logarithmic expression, we're going to equal this to a variable, let's say x. So that from here, we can go ahead and change this to its exponential form. That is square root of 13 raised to the power x equals 13 raised to the power 2/3. So I'm going to go ahead and write that down here. Please remember again that this square root of 13 can be changed into 13 raised to the power 1/2. So this expression that we have here can be simplified as, now if you notice their bases are the same, this tells us that these two exponents that we have here are equal each other. So I'm going to go ahead and show the work on how to solve for x on the side here. Since we want x by itself, we're going to multiply 2 to each of the sides. It's pretty much like 2 over 1. And then multiply this by 2 over 1. So then we go ahead and cross out 2 and 2 here. So then our x is equal to, that's 2 times 2 is 4. And then 3 times 1 is 3. So this whole expression that we have here is equal to 4/3. Now let's have another example. To evaluate this expression that we have here, we're going to equal this to a variable, let's say y here, so that we can go ahead and change this into its exponential form. That is the cube root of 27 raised to the power y is equal to 27 raised to the power 2/3. This cube root of 27 can be written as 27 raised to the power 1/3. So I'm going to go ahead and show that work down here. Now, this expression can be simplified as, now notice that their bases are the same, so that we can go ahead and say that their exponents are also equal, so that I can go ahead and show the work to solve for y on the side here. So the value for this whole expression is 2. So that is how we evaluate logarithmic expression without using calculator.